Today we're going to talk about quadratic inequalities, and we're going to start with our two variable ones, which means we have an x and a y. And we'll start by graphing those. So it tells us here that we are going to sketch the graph of the parabola as if it was an equal sign. So we sketch that parabola like normal, those points. We determine if it is a solid line or a dashed line by the inequalities. If it's got an equal sign here, then we want a solid line because every point on that curve is a solution. If it does not have an equal sign, we do not want it equal to our parabola, to our curve. So we have a dashed line there showing those are not solutions to our problem. Then it says we test one point inside the U-shape and one outside of the U-shape. Whichever one comes out to be a true statement, that's where our solutions are found. That's where we shade. So let's talk about one. And we're going to review some of the concepts from previous lessons just to make sure we keep spiraling those in. So right here, they have given us this in the standard form. And so in the standard form, we know that the C value is the y-intercept. So we have a y-intercept here at -3, so I can graph that first. And then we also know that if the A value is positive, which it is here, then it is concave up. So we know it's going to be some kind of parabola that goes upward, something like that, or like this. But that's really all the information that the standard form gives us. So in order to finish graphing this, we need to convert it to another form. And the easiest form to graph from is our transformational form, or vertex form. To do that, we complete the square. So that's what we're going to do here. When we complete the square, we want to make this a perfect square trinomial. So I'm going to find what the missing term is for this to be a perfect square trinomial. We'll just leave that -3 there at the end. And so in order to find that, we take this middle term, divide by 2, and then square it. So 2 divided by 2 is 1, squared is 1. Now we can't just add 1 to an equation because then we've changed the value. So whatever I do to there, I'm going to subtract it here at the end so that we are keeping our equation balanced. Now that we've kept the equation balanced, we can go ahead and factor. And so we factor this first part here. And since it's a perfect square trinomial, it is going to factor to be x and then whatever half of this is. And so 2 divided by 2 is 1. And they're the same factors, so we get the square. Now the -3 and -1 give me a -4 at the end. So now we've converted it to the transformational form, or the vertex. That equation gives us a lot of information about graphing. So it gives us the vertex. The vertex is these two values right here, our C and our D. This went to the left one, so the x value of the vertex will be -1. This went down 4, so the y value is going to be -4. So I go to -1, -4, and there's our vertex. Now the axis of symmetry cuts right through the middle of the vertex, and it is a vertical line. So it would be x equals -1. And that means anything that happens to the right happens to the left, so we also know this point right here. That's really enough to graph our parabola, but we could pick other points. There's no stretch or compression here, and so we know that the parent function goes over 1 and up 1 to get this point, and it goes over 2 and up 4 to get the next point, because 2 squared is 4. And whatever happens on one side also happens onto the other, so now we have more points for our parabola. Had we factored this, we would have gotten these two roots too. Remember, when we factor, that's what it gives us is our roots. So let's practice that real quick. When we factor here, we're looking for what multiplies to be -3 and adds to be 2. And so this factors to be x plus 3x minus 1. +3 and -1 multiply to be -3, and +3 and -1 add up to be a +2. And so when we find our zeros, we make that equal to 0 because that's how we get our x-intercepts. It's when y value is 0. And so that gives me that -3 in this factor and +1 are my roots. And so sure enough, -3 and +1 are my roots. All right, well, this has a equal sign here. So every point on this curve is a solution. We want it to be equal to the curve. So we're going to go ahead and make a solid line. And there is our parabola. Now, to determine where our shading occurs, you pick any point on the graph, inside or outside, to verify if it is a true statement or not. One of the easiest points to plug in is 0, 0. So that's usually where I start right there, this point here. And so I'm going to plug in 0, 0 to my equation. When I plug in 0 here, 0 squared is 0. 2 times 0 is 0. So the only thing left on that side is -3. And we plugged in 0 for y. So we determined, is this a true statement? Remember, the bigger number has to be on the open side of this inequality. And -3 is not bigger than 0. So this is false. So I know my solutions are not on the inside of this parabola. That means that the solutions are on the outside, the opposite side. I'm going to go ahead and shade, but I'm going to go ahead and test a point too so you guys can see that. So I pick any point on the outside. And so I'll pick 5, 0 right here. And we plug that in. So 5, 0. I plug in 0 for my y, and so I have that right there. Then 5 squared is 25. 2 times 5 is 10 minus the 3. And so 25 plus 10 is 35, minus 3 is 32. So 0 is less than or equal to 32. That is a true statement. So that's where my solutions are, wherever that point is, and it is on the outside, so we shade the outside. There's one. Let's try another one. So we're going to try this one down here. I start by finding my y-intercept, which is at -8, and so I graph that. This too is going to be concave up because the a value is 1, so that's concave up there. This one here, I'm going to go ahead and factor and get the roots first so that you can practice that. And so we get what multiplies to be -8 and adds to be 2, and that's a +4 and a -2. I left the inequality there, but what we're finding is our x-intercepts, so I'm going to go ahead and put that 0 equals there. So x equals -4 and x equals 2 are our roots. And so I would go ahead and graph those. Our x-intercepts are right there. All right, to keep this going, I'm going to go ahead and find our vertex. We can go ahead and complete the square again in order to find our vertex. And so I get x squared plus 2x. Now that happens to be the same number we just did up there, so we know it's going to be 1. And then I get -8 and -1. This keeps it balanced. And so when we graph here, we find that our vertex is at -1, -9. And so I go to -1, -9, and there's my other points. Now in this case, my axis of symmetry, again, is x equals -1. I'm going to go ahead and review, though. You can get the axis of symmetry from our standard form. It is x equals -b over 2a. So -2 over 2 times 1, which is -2 over 2, which is -1. We already knew that because it goes right through the vertex there. For those of you that don't remember, we did our quadratic formula last time. That -b over 2a is that first part of the quadratic formula. So the axis of symmetry formula is that first part of the quadratic formula. All right, for this one, there's no equal sign here, so we don't want these to be solutions, so this is going to be a dashed line, or dotted. And so there is our parabola. Now, we test points inside or out. Again, 0, 0 is not on the curve, so I could use that one to test. That's one of the easier points to test. I plug in 0 there, and I get 0 is greater than 0 squared plus 2 times 0, all of that is 0, is -8. Now, this one is a true statement. 0 is bigger than -8. So wherever 0, 0 is at, that's where my solutions are. So in this case, this one is on the inside. So I'm going to shade my inside, and all of these are solutions. All right, good work. You guys go ahead and try this fourth one. Go ahead and pause the video, come back, and let me know if it is correct. Here you go. Check your work. This is what you should have gotten. This one was shaded on the outside of the curve, and it was a solid line since there was an equal sign. All right, the last thing we're going to do with the two variable ones here is going to be a system of equations. Back in Unit 1, we talked about system of equations. That's when we had more than one equation to solve. So here we've got two. And we did some with the lines as well when we did linear programming. Remember, if you had two equations, the part that we cared about was the double shaded area. If we had three equations, we wanted the triple shaded area. That's going to be true here too. So we're going to want to graph both of these and then find where that double shaded area is. So for this first one, y is less than or equal to negative x squared plus 4. Here is my vertex. This is written in the vertex form. The c part is 0. That's why there's nothing written with the x there. So 0, positive 4 is my vertex for that one. It is open downward. This is concave down because the a value is negative. And so instead of going over 1 and up 1, I would go over 1 and down 1. And so here is my next 2 points. And then when we go over 2, we're going to go down 4 because x squared is 4. And so there is a good amount of points for us to graph this. We do want a solid line with this one because it does have an equal sign. So we get a curve like this. I plug in my 0 as my test point on this one to see if that works. When I plug in 0 here, I get 0 is less than or equal to negative 0, which is 0, plus 4, which is 4. This is a true statement. 4 is bigger than 0. So my solutions are wherever 0, 0 is, which in this case is down here. So inside of my parabola here, I'm going to lightly sketch because the part I care about is that double shaded one. And so now we've got x squared minus 2x minus 3. So I know that my y-intercept is at negative 3. So I can go ahead and graph that. I'm going to have to convert this again to the vertex form to help me out. And so that's a plus 1 minus 3 minus 1. I factor and I get x minus 1 squared minus 4. So my vertex is at 1, negative 4 on this one. So I'm going to go to 1, negative 4. And so there's my first 3 points. This one is going to be a dashed line since it does not have an equal sign. So I won't connect my points here. It's going to be a dashed line. I can check 0, 0 here. It's inside of my parabola again. So I'll check that same point for the second system. When I do that, I get 0 is greater than negative 3. That again is true. So that's going to be inside of my parabola. So we are shading all of this part, which means that the double shaded area is this part inside here. That's where my true solutions are. That's where it's a solution to both equations. So that's where my inequality is shaded. All right, now we're going to talk about the one variable quadratic inequalities. And so that's where we don't have a y value or we plugged in 0 for our y, either one. So here we've got x squared minus 2x is greater than 15. Anytime we're solving a quadratic, our first step is always to get it set equal to 0. So that's going to be my first step here. I'm going to bring over that 15. So I get x squared minus 2x minus 15 is greater than 0. Now you've learned several ways of solving a quadratic. You can complete the square, you can graph it, you can factor, you can use the quadratic formula. Most of these factor, so that's going to be the easiest way. So I'm going to go ahead and factor this. X times x. And we're looking for what multiplies to be negative 15 and adds to be 2. And so that would be negative 5 and positive 3. And so then the two solutions are x equals 5 and x equals negative 3. These are the 2 points where my equation is equal to 0. So since there's no equal sign here, when I draw my number line, those are going to be open circles because it is equal to 0 here, and this does not have an equal sign. So that's my first step. Now, I want to know where it's greater than 0, and that's the positive numbers. So I don't really care what the number comes out to be. As long as I know if it's positive or negative, I know it's going to be a solution. So we think about a number to the left of negative 3, like negative 10. If I plugged in negative 10 into this first parentheses, it would be negative. And if I plugged in negative 10 to the second one, it would also be negative. So a negative times a negative, because these two are being multiplied together, give me a positive. Then I test a point in between -3 and 5. 0 is a good one there. If I plug in 0 to this first parentheses, it's going to be a negative. If I plug in 0 to this second parentheses, that's going to come out positive. So that is a negative times a positive. And when you multiply a negative times a positive, you get a negative. The last part here, let's say positive 10, that would be positive, that would be positive, and a positive times a positive is a positive. So now I figured out what the numbers would be in each one of these sections. And so we're looking for the ones that are greater than 0. Well, the numbers that are greater than 0 are positive numbers. And so all of these would be solutions, and all of these would be solutions. And so we write that as -infinity to -3, every single number in there. And remember, I'm going to use parentheses because that's an open circle. And then 5 to infinity, again using parentheses because that's an open circle. So those are all of my values that are answers to this. All right, let's do another one here. In this case, we've got a negative sign. And so I'm going to factor out that negative first before I even get started. Forgot to factor that correctly. A negative times an x squared gives me a negative x squared. A negative times a negative 2x gives me a positive 2x. And a negative times a positive 8. All right, now we're ready to factor our trinomial. I don't like having a negative in front of the x squared or anything really to make it easier. And so now x times x gives me x squared. And then we're looking for what multiplies to be -8 and adds to be -2. Well, that's a -4 and a positive 2. And so my two solutions here are x equals 4 and x equals -2. Again, we do not have an equal sign, so these are both going to be open circles. Now in this one, we do need to take into account this negative, because negative times this is going to happen every single time. So we know our first value is always going to be a negative. Here, I can go ahead and get that part started. Now, for a value smaller than -2, -6, let's say, I plug that in here, that's going to be a negative. I plug in -6 here, that's going to be a negative. So this is a negative times a negative times a negative, which is negative. 0 in between here, if I plug in a 0 here, 0 minus 4, that's going to be negative. 0 plus 2, that's going to be positive. And so a negative times a negative is a positive, times a positive would make all of these values positive. And then the last one's 10. That would be positive, that would be positive. So positive times a positive is a positive, times a negative would make this a negative. With quadratics, you're always going to end up with two of one of them, because if you're thinking about that, it's going to look like this or it's going to look like this. So they're both going to be either going to the negative or to the positive there. All right, to determine our answers here now, we want the ones that are greater than 0. So again, we want our positive values. Well, in this case, our positive values are right here from -2 to 4. And again, parentheses, because those are open circles. All right, there's one for you to try there. So go ahead and pause the video, give that one a try. Remember, step 1 should always be getting it set equal to 0. So do that first. All right, check it out. You should have factored it to be x minus 6, x plus 3. And then you should have shaded. And here we wanted the numbers that were positive again, and those were the outside ones. So -infinity to -3 and 6 to infinity. That should have been your solutions. All right, the last thing we're going to do is a word problem. So it says the path of a football kicked from the ground can be modeled by h equals -0.02x squared plus 1.2x, where h is the height in feet and x is the horizontal distance in yards from where the ball is kicked. The crossbar on a field goal post is 10 feet above the ground. So that means this part right here is 10 feet, that height. Now write an inequality to find the values of x where the ball is high enough to go over the crossbar. So we want to put that 10 in for the place of h, which is our height, and then we put in our curve value for the football. So that's the parabola that makes this football path, okay? That's what this is. negative 0.02x squared plus 1.2x. We need to determine what the inequality is that's going to go in between there. And so if we think about that, we want it to be bigger than 10 so that it's up here and past that 10. So that means that my curve is where the bigger one value should be. So I've got the inequality open up towards that. Then I got to think about, do I need an equal sign there? Well, no, if I had an equal sign, then it would hit the crossbar, doink, and it'd fall back out. We don't need that. All right, so now it tells us to solve the inequality. Since this one has some strange numbers, this would be on your calculator portion. So let's talk about solving this on the calculator. I could go to my y equals and put negative 0.02x squared plus 1.2x. And then in y2, I'm going to put in a 10 for my crossbar. Now I'm going to have to adjust the window because the regular window on the calculator is from negative 10 to 10. And so this is going to go beyond that. For the x max, that's my horizontal distance. So Aubrey just hit a 60-yard one the other day. So let's go beyond 60. We'll go to like 80. And then this football is going up in the air. So we are going to need it to go higher than 10, obviously. So let's go something like 50. We hit graph. There is the path of our football, and there is our 10-foot crossbar. So all of these above that are my solutions because that's where it's above the 10 feet. Here it's below the 10 feet. And then at that point of intersection is where it is at 10 feet. So I hit second trace intersect. And so move over to my point here and I'm going to hit enter, enter, enter. So the first time that it hits 10 feet is at 10 yards. Then it stays above the 10 yards. Second trace intersect again. It stays above 10 yards for all of these values. It's above, 10 feet. It's above the 10 feet right there till it gets to here. And then we hit enter, enter, enter. And so that intersection is at 50 yards. So from 10 to 50 yards, it is high enough to get above the crossbars. So it tells us a player attempts to kick a field goal from 52 yards away. Will the ball have enough height to go over the crossbar from the distance? Well, the answer to that would be no. 52 does not fall within 10 and 50 here. So it would not make it. That would be where it is over here below the 10 feet. All right, that was quadratic inequalities.